Okay, it looks like everyone's here, so let's go ahead and get started. Good morning, good afternoon, good evening, depending on where you're joining us from today, and welcome to today's Intelligence Operations and Automation Solution demo. Looking at the attendee list, I think I know many of you from the communities, but for those of you who do not know me, my name is Len Thompson, and I'm the Community Manager for all of CA's mainframe and workload automation communities. Before we get started with today's session, just want to let you know that I see most of you are listening to this via the WebEx audio broadcast, which is great. But if you have any questions, you will not be able to ask verbally, so we ask that you please use the Q&A box right in the WebEx. If you don't see that box in the lower right of your screen, in the upper right, there is a question mark icon, so if you click on that, it will open up for you. Please feel free to use that throughout the session, and yeah, so ask your questions throughout the session, and the team will answer as many of them as we can. And with that, I'd like to introduce David Myers, who's the Offering Manager for Mainframe Operational Intelligence. He's going to kick us off, and then we'll move on to the demo. So take it away, Dave.
Thanks, Len. Hopefully the background noise isn't distracting. But I'm out here at IBM if anybody else is here and wants to talk about any of this. I just wanted to kick things off with talking about the three things that we're working on. So John, if you could go to the next slide. So as part of our solution, we're really working on three distinct things. And I wanted to call this out because one of the common questions that we're starting to get is, what do we get with various stuff like SYSVIEW or NetMaster, or what's in an MOI SKU or in DCI? So the first thing we're working on, John, if you could hit the button, is what we're calling our machine learning core capabilities. Now, some people have referred to this as the OI platform or MTCOI or a variety of other different names. So we're really trying to clarify and just talk about, these are the core pieces of our technology stack that we're building. And we're shipping in multiple places, such as in SYSVIEW, such as in NetMaster, and such as in a new product we came out with called Mainframe Operational Intelligence. And I have a couple of slides that's going to talk about what's in each of these. So John, if you get the next button. The next thing we're working on is CA Mainframe Operational Intelligence. So this builds on top of those core capabilities, and we add some additional new machine learning algorithms and so some new workflows and some new technology above and beyond what we find in the core. This is a separate purchase from what you traditionally would get with a SYSVIEW or a NetMaster, and we're going to talk a lot about what's unique and what we've added into it in the course of this session. The third thing is a new offering we have called CA Dynamic Capacity Intelligence. So this is something based on some technology that we've brought into CA. We're integrating it into the rest of our portfolio, and JD is going to talk about what that offers and the kind of problems it solves. So moving to the next slide, just to talk a little bit about each of these before we get into the What's New session. We talk about our core machine learning capabilities, and really what we're doing is we're embedding this technology in multiple places. We're taking this technology and we're putting this core stack into CA SYSVIEW, into CA NetMaster, into that new Mainframe Operational Intelligence offering that we put out. And really, it's all around this common stack of technology to give you some big data infrastructure, to give you some machine learning capabilities, and focused on two or three big use cases. In here, we have self-service views to help you visualize, help you explore, help you analyze that data that you're already gathering today. We'll allow you to analyze those metrics, automate responses off that, using what we call adaptive thresholding, or what you may have heard of as the green highways. And we try and make this easy to deploy and easy to manage by giving you a virtual software appliance. So a lot of this is what we've been talking to you about over the course of the last year. We have our software appliance. In there we have things like that big data store. We have machine learning algorithms and DSP and anomaly detection. But we're focusing on how do you collect that data, how do you analyze it, how do you take that, use green highways as an example, to drive out to automated responses using things like Ops MBS. Or now we've introduced some new features we're actually calling off to Mainframe Application Tuner. The goal here is to really take the products that you have and enhance them with some new machine learning technology and give you zero-cost access to that stack so that it makes it easy for you to pick up other things and other technologies that we're bringing out to just work with what you have today. So on to the next slide. Now, next we have CA Mainframe Operational Intelligence. So this is a new thing that we put out, but it is a separately charged. This is focused on what I call issues. So the first thing that core technology, we were looking at metrics, and we were looking at driving thresholds and when new anomalies occur and how do I drive that all. With MOI here, or CAMOI, excuse me, we're looking at what I call issues, which are more complex situations. It's where we're looking for when multiple trends start to correlate. It's when we're trying to drive and figure out that 8, 9, 10, 12 different alerts actually mean something that you have to take action on. And we're bringing that concept of an issue forward and really putting intelligence around it, such as how has this happened in the past? Helping you drive predictions about, in 30 minutes, this may be the next set of things that can happen. And starting to take input from you as a human, not just looking at the machines, to actually drive better and more reliable predictions over time. It's all about driving faster, driving smarter, driving simpler operations of what you actually have to do and augmenting the way that you work today. So it's all about that earlier action, trying to show predictions about what may happen next, not just that you're sort of trending out of norm. It's about helping take that information and driving down to what a root cause may be. It may be that storage does something, and then CICS does something, and then TCP/IP does something, and then 19 other things happen. Which of those are really the important things for you to stare at? We help give you views and ways of analyzing and drilling down, not just for you on the systems team, but also helping the generalists or the people in operations collaborate around this. So we're really focused on helping to proactively or predictively detect complex patterns, not just anomalies on single metrics, and really help drive down that remediation time or even help prevent those outages that may occur or those performance issues that may occur. So it uses that core thing I talked about, but it adds a lot more in a lot more complex situations. The third thing is CA Dynamic Capacity Intelligence. So this is a new thing that we brought out sometime mid last year. A lot of you may not have heard about it yet, but it's very it's very aligned to what we're doing with our core machine learning and with CA Mainframe Operational Intelligence. It's really driving and looking at how you're utilizing your mainframe capacity and how you're utilizing your MSUs and being able to drive automation from the information that we gather to balance between meeting an SLA, driving a certain cap level, how much cost that's going to push back to your business, and help make those decisions dynamically and automatically to help balance between all those different variables that you have to consider when you're near a cap or when you're close to an SLA, violating an SLA. So it's all about improving your ability to adhere to those SLAs, manage them better, make sure your critical workloads finish on time, automate and balance in between one LPAR and another to actually keep your costs down, as well as avoid or help work around those unplanned spikes and those unplanned peaks that may be happening that may drive some MLC, cost rising in your shop. So JD is going to get a lot deeper in this. I just wanted to give you a highlight before we get in the three different chunks. So now I'm going to hand it off to JB, John Benbow, who's going to talk a little bit deeper about all the individual things we're going to talk about, following those three things that I mentioned. First, with what's new in our core capabilities. You'll see this show up in SYSVIEW and NetMaster and MOI. What's new and what's unique in MOI that you may have some interest in, as well as what's new and what's unique in DCI. So John, over to you.
Thanks, Dave. So again, welcome everyone. My name's John Benbow, and I'm part of the product management team working on Mainframe Operational Intelligence and Machine Learning. So today we have subject matter experts demonstrating the latest features that are available to you now. To start things off, the new features that are available as machine learning core capabilities will be demonstrated. These include special business days, reporting enhancements, and CA Mainframe Application Tuner integration. We'll then demonstrate what's new and unique to Mainframe Operational Intelligence, covering issue intelligence, integration with CA App Experience Analytics, CA SYSVIEW performance management option for DB2 integration. We'll talk about publishing insights from Mainframe Operational Intelligence to Splunk. Then, as Dave mentioned, JD will introduce everyone to CA Dynamic Capacity Intelligence. We'll demonstrate that product and how it's integrated in Mainframe Operational Intelligence and the new features available in that product. And then we'll open up the session for questions. So all the questions and feedback you place into chat, we'll address those at the end of the presentation. So thank you again. Thanks for taking the time, and I hope you enjoy the solution demonstration. So to kick us off, Jeff Bogue will run through special and exclude days. So over to you, Jeff.
Thank you, John. My name is Jeff Bogue, and I'm one of the developers on the team, and I'll be talking to you about special days support. Let's go to the next slide, John. So special days support is a new feature that we think you'll find really useful. Since you are the experts regarding your system, you know that there's certain days that you expect your system to be performing outside of what would be a normal range. For example, payroll days or holidays or special shopping days. On days like those, you typically would not want to be bothered by alerts or abnormal system performance. Also, you may not want future normal day predictions to be influenced by abnormal activity or outages. So we give administrators the ability to easily define days that are considered to be special, in other words, different than your normal day. This will prevent alerts from occurring during that time frame. More importantly, it allows green highway predictions to be made based on the special day without influencing green highway predictions for normal days. We also give administrators the ability to exclude specific time ranges for future green highway predictions. This will prevent unplanned outages or unexpected abnormal activity from influencing future predictions. Let's go to the next slide. So let's think about the differences between normal days, special days, and exclusion days. A normal day is a day where you want to be alerted if something abnormal is happening in your system. You also want that day's performance characteristics to teach the green highway what to expect for normal days in the future. A special day is a day where alerts would be extraneous noise that you don't want to receive. However, you still want to teach the green highway what special days like this day look like. An exclusion day is a day where something went horribly wrong, perhaps an unplanned outage or a catastrophic system failure. You do not want this day to teach the green highway at all. It's just a day that you would just like to forget. So let's take a look at some quick examples. In the top green highway example, a special day range has not been defined. Here, the CPU utilization that had been hovering around 20% spikes up and causes an alert to be generated. In the bottom example, a special day range has been defined. The CPU spikes up, but an alert is not generated. And this is because alerts are not generated while a special day range is in effect. So let's go to the next slide and we'll see one of the benefits of special days. So imagine having payroll days at regular intervals. You would like to be have more accurate predictions for payroll days by looking at previous payroll days. You would also like these payroll days to not affect green highway predictions for normal days. If you didn't have a special days calendar, you can see that the high peak on a payroll day affects the normal prediction or the prediction for normal days. But by uploading a special days calendar file that specifies the time ranges for payroll days, you can see that as soon as the payroll day ends, the prediction for CPU utilization is the same as it was on the payroll day, or before the payroll day, back around 20%. The next payroll day expects the CPU utilization to go back up to 80%. Let's go to the next slide and look at our last example. Imagine that we had an unplanned outage that caused high CPU utilization. In the top green highway, you can see that future predictions are indeed affected by this unplanned outage. We can upload an exclusion days calendar file that specifies the time range of the unplanned outage in order to exclude that data from future green highway predictions. As we can see from the bottom green highway, after we upload that exclusion day calendar file, our bad day is no longer considered in future predictions. Let's go to the next slide, John. So DocOps has a lot of great information about managing the special days and exclusion day calendars. It explains how to use the appliance controller to upload calendar files as well as the format of those calendar files and the validation rules that apply to them. DocOps also has some great examples of when it would be appropriate to use a special day or an exclusion day. So take a look at the DocOps section for calendar management so that you can see exactly how to start using this new feature. Back to you, John.
Thanks, Jet. Appreciate it. So that was a good rundown of business days and the value that feature provides customers. So if anyone on the call has questions, please send them through in chat and we'll answer them at the end of all the demonstrations. So now we'll hand it over to Mashindra to talk about reporting enhancements. Over to you, Mashindra.
Thanks, John. Reporting and dashboarding feature was introduced in 1.0.01 release. As a system programmer and administrator, it allows you to easily create ad hoc views and dashboard of performance data for historical analysis. However, this analysis was only allowed for 45 days history data. With the new release, a new service has been introduced called Rollup, which allows you to perform historical analysis beyond 45 days. You can continue to generate reports and dashboard for last 45 days as usual. It allows you to get insights with granularity of minutes. This is high fidelity data. Beyond that, the Rollup service aggregates the data and maintains the hourly and daily basis. With this, you can create reports and dashboards for historical analysis up to 2 years. So the business value of this feature is more accurate and actionable insights. John, can you move to the next slide, please? So here's an example. You can see that I have created a report for CPU percentage metric for one of the LPAR. And the timeline selected for this particular report is December 19th, 2017 till the month of March. So the data fetched for this particular report comes from the aggregation. And you can see the aggregated data is presented for you to do the historical analysis, letting you know how your CPU is performing for that particular LPAR beyond 45 days. So with this, you can actually look up the history data for the last year on a special day and find out how the system was then compared to today. Next slide, please. You can continue using the existing 45 days high fidelity data. You can see that you can zoom in this report and get the historical data minute by minute. So on the x-axis, you can see that the data has been fetched for each minute and displayed for your analysis. So with this feature, you will be able to identify your performance bottlenecks beyond 45 days. That's all I have. Over to you, John.
Thank you, Machindra. Thank you for that. Okay, so Rakesh will now talk about CA Mainframe Application Tuner integration into Mainframe Operational Intelligence. Over to you, Rakesh.
Thanks, John. Good morning, good evening, everyone. I'm Rakesh, and today I'll be talking about CA MOI and CA MAT integration, which is part of the latest series of CA MOI. So traditionally, on a regular basis, the code changes done are not studied for performance analysis, and we end up with performance issues. Most of the time, the analysis is a manual process, and it takes significant amount of time to debug and fix the issues. To solve these problems, we have built an integration of CA MOI with CA MAT. With this integration, when an anomaly is detected in CA MOI for a poorly performing job, the anomaly is automatically sent to CA-MAT for analysis. The response of the analysis can be visualized in the CA-MOI UI, and the operator monitoring the mainframe can look at this and inform the system programmer about this problem. The system programmer can then log into the MAT UI for further drill down of the MAT analysis report for this particular job, and he fixes the problem. With the adaptive thresholding and dynamic alerting built-in capabilities of CA-MOI, since the problem is fixed from the system programmer, we no longer see the alert in the alert console for that particular job in CA-MOI. By using CA-MOI to detect the anomaly and automatically invoke a CA-MAT measurement, let the mainframe management team and the development teams to identify problems early and tune the application performance quickly before a major issue occurs. I'll demo. John, can you make me the presenter?
Yeah, you should have it now, Rakesh.
Okay. I hope you all can see my screen. So this is the CA-MOI alert console, and you are looking at the alert console and all the alerts generated. So as an operator, I want to monitor the job IO rate, and looking at the alert console, I'll see that for a particular alert with severity 2, there's some automation ran against that alert. So when there is an automation, when this alert was sent to either CA-MAT or CA-Ops event management, we see a wrench icon here, and which signifies that this particular alert was sent for analysis or to be automated by CA-Ops. So you can see the green highway here, and go to the automation tab, and at the bottom here we can see various actions taken for this particular alert. So first one is the insight sharing, second one is event management response, and third one is application tuner response. We'll drill down and see what's the problem with this particular job. So at the top we see the job information, the start time, the monitoring statistics, the start date and time, and the duration. And at the bottom we see the various delay types for this particular job. So the first delay type is waiting for CPU in the module dot nucleus, and if we see here, it was waiting for more than 99.4%, and the other delay type is waiting for SVC in the module DynasCP, and this was waiting for 0.55%. So now the operator, looking at this and with this additional information, he can go back to the system programmer and inform him about these delay types and also the job name, and the system programmer would look at the code and fix the problems in the code, and this would resolve the problem, and he would never see he will not see the alert for this particular job. That's all for the demo. Thanks. Over to you, John.
Thank you, Rakesh. Okay, so that was a good demonstration around the integration with Mainframe Application Tuner and the value that provides. I think that's pretty powerful stuff. Thank you, Rakesh. So, Machinder, over to you to talk about another very powerful feature, issue intelligence.
Thanks, John. I'm pretty excited to talk about issue intelligence today. So, anomalies comes from various subsystems such as system tasks, resource databases, application. Most of the time, the cause of these anomalies are one single problem. Manually correlating these alerts and identifying root cause is time-consuming task. MOI with this release introducing alert clustering capability, which will correlate the alerts that are happening in near neighboring time consistently, coherently, and repeatedly. This also helps in identify the next major anomaly that is going to happen. I will explain this in a minute. This new capability helps in reducing outages early as possible. It will help junior staff by more accurate and actionable insights. In turn, reduces the MTTR and operational cost. Let's try to understand the alert clustering machine learning capability in details. John, can you move to the next slide, please? So there are 3 steps involved. The first step is gather alerts from multiple sources. So imagine that we are getting alerts for some of the metrics originated from SYSVIEW, NetMaster, or DB2 detector, or any other sources which are integrated with the CMOI. The second step is to actually find out the set of alerts which actually occur together consistently and coherently, and build a pattern out of it without you defining a set of metric as a group. So this happens automatically and registers different patterns as the alerts are seen by the machine learning algorithm. In the third step, once the patterns are identified, it keeps on watching the newly incoming alerts, and if there is a match, the pattern is happening at this moment, it actually generates a new type of alert called issue alert. So that way, you need not actually correlate manually all the alerts and find out a situation to act on. Instead, MOI helps correlating, finding the patterns, and identifying issue alerts for you. In the next slide, we'll go in detail, discuss about cluster identification and prediction. So just for demonstration, in this slide, we see number of alerts which are occurring in your system. So on the y-axis, you have metric. On the x-axis, we have time. So let's start from the left-hand side. You can see a box with some of the alerts shown. So the machine learning capability identified a group of alerts which are coherent. After some time, it finds the same group occurring again. So it is consistent. And if it repeatedly sees the same group occurring, then it is repetitive in nature. So that way, now we have a pattern, and we will call it as a cluster X. So once the machine learning capability identifies the cluster X, and the new alerts are coming, and majority of those alerts are matching, that time it raises a new issue alert, which is a set of alerts that you should be looking at. Now let's try to understand the prediction capability. Let's go back to the left-hand side again. As cluster X is happening, maybe the cluster Y is also happening. Again, it identifies cluster X is happening, it is followed by cluster Y. That means there is some sort of relationship between these two clusters. That means there is some sort of relationship between situation A and situation B. So when the situation A is happening, we can predict situation B. So that's about alert clustering. Let's have a demo. John, can you make me presenter, please? So I logged into MOI. I can see a set of alerts here originated from various GOS jobs. And there are several metrics which are beyond normal range. I can see CPU percentage, storage metrics, and channel metrics and network metrics which are reported as not behaving as per the normal range. If I have to find out a problem by correlating all those manually, it is time consuming. With alert clustering, we get the issue alert, which presents all those set of alerts which are failing together, occurring together as a group to act on. So I selected issue as a filter in the alert console, and I can see a different icon here. This represents issue alert. It has got a severity 1 and the time when it was detected, how long it was sustained, and what was the identification of that particular pattern. So let's actually drill down on this particular issue alert. If I click on that, it actually pops, it opens a group of alerts which are part of this particular issue, and I can see there are several alerts reported with respect to network. So that way, you need not to correlate them manually. Perhaps there is some less network activity than usual, and hence this particular issue alert has been raised. You can drill down and find out which particular network application is in the alert state. You can see this particular network application, and you find the severity, the metric value, and rest of the details as usual. So let's actually find out some more details about this issue. You can see this particular issue ID 86 is reported as a major issue, and it also occurred in the past in these times. So you can now recall what change, what configuration change, what application change was made, which resulted into this particular issue. Not only issue, but it can also predict when this situation is happening, what else is going to happen in the future. I can see on the right hand side, we have issue predictions. So issue ID 86 is occurring at this particular time, leads to issue ID 229, 71, 72. Let's find out more details about them. It actually gives you the probability and also gives you when it is going to occur. So it says 20th December it is going to occur at this particular time, and also gives you plus minus error rate. If you want to know more about what is going to happen, click on the related alerts, and it gives you which channel, which job is going to have trouble when the issue ID 86 is happening at this moment. It also gives you more details, like say when this particular predicted issue alert occurred in the past. Now you have complete history of the issues, and you can connect the dots. You can collaborate on this particular issue with your fellow analysts by using the annotation tab. Here you can actually leave your remarks. You can also automate to take the automated corrective measure for this particular issue. And once this issue is resolved, then it will be taken out from the system. Now this is about the issue and issue details. Now let's move on to the next part. So here is yet another issue. I can see that the issue occurred, and there are several network matrices gathered together, which happen to actually go beyond the normal range. Possibly there is a huge network activity happening, and you can actually figure out which jobs are causing those network activity. You can select one of them. Maybe that's the root cause of this particular issue, and you can record this as a root cause. So once you record this as a root cause, possibly we can utilize that particular root cause in future to provide you a suggested solution. The next part is about the user feedback. Imagine that if the issue ID 4 is the one which helped you solve the problem faster, and that was definitely helpful for you, then you can record the user feedback by clicking one of the button, like say, I like this, and this way this particular feedback gets recorded, and next time this information will help us to show you more or less of these issues, so that the system will be more accurate and will provide you actionable insights. That's all I have today. Over to you, John.
Okay, thanks, Shindra. Hey, Len, can you give me the ball? I don't seem to be able to get the ball. Thank you. So, Shindra, there was another slide. Do you want to talk to this or not?
No, I covered that. Thank you.
Okay, so back to Machindra to talk about our integration with CA App Experience Analytics.
All right, so enterprises often have different support staff for distributed and mainframe products. When an enterprise solution spans across distributed and mainframe, you need a collaborative effort from different support teams to diagnose issues. This process can be time-consuming and complex. With this release, CAMOI lets you integrate with the CA App Experience Analytics to help you move from reactive system to proactive system. CAXA, that is CA App Experience Analytics, is a digital experience monitoring analytics solution. With this integration, you can easily correlate distributed and mainframe products to find and predict group of alerts known as issues. Imagine you have a mobile app or web app connected to some services on mainframe. CAXA can identify the app experience problem like HTTP response delay. And this could be caused by distributed service or could be caused by mainframe service like DB2 subsystem. By correlating distributed alerts with the mainframe alerts, one can find out the root cause quickly and notify the respective team. Let's have a demo. We are back to the alert console screen. You can see that I have filtered the alerts by issue, and you see all the issue alerts are seen on the screen. There are several issue alerts reported. Let's actually find out this particular issue ID 4. Now I can see there are a number of network metrics reported. Perhaps there is abnormal network activity happening due to these particular jobs running on mainframe. Then there is particular job which says that the metric real storage in the abnormal case. Then this particular metric, which is very interesting, that is pulled from CAXA analytics solution and correlated with mainframe alerts. So you can see this particular alert originated on the distributed side, whereas rest of the alerts at this very same time occurred on the mainframe side. Those two types of alerts correlated, and it has found a situation. Now, by looking at this particular screen, one can quickly identify what's really happening when the customer is facing application performance delay in the field. What is really happening on the back end? Is that the distributed problem, or is that the mainframe problem? Now you can see that this particular HTTP response time has been correlated with this particular metric. You can choose one of them as a root cause and record that into system, and that way you can quickly identify whether the problem is caused by distributed service or mainframe service. That's all I have, John.
Thank you, Machindra. Len, can you give me the ball again, please? Thanks.
I'm trying to give it back to you. It's taking a minute.
Yeah, go.
Hello, John. Can you hear me?
Yeah, over to you, Tom.
Okay, great. Hello, everybody. Welcome to our solution demo. My name is Tom Keltica, and I'm the product owner for SYSVIEW for DB2. Today, I will introduce to you our new integration with Mainframe Operational Intelligence. Next slide, please. Our integration with MOI was made available in Release 20 of SYSVIEW for DB2 at incremental release number 3. There is a CA Common Services component called CCS Z Data Mover that must be installed prior to any attempt to use MOI integration in SYSVIEW for DB2. Once you have these two components installed, activating the feature is as simple as flicking a switch. A SYSVIEW DB2 sysparm called IQL define is updated with the value MOI equals yes. And when you bring up SYSVIEW for DB2, data will begin flowing to MOI. Next slide, please. When you go to the MOI appliance, you will see a new category now. It's called DB2 Statistics. And if you expand that category, you will see 4 subcategories: CPU, subsystem, connection, and buffer pools. If you select a subcategory, say CPU, you will be shown individual CPU metrics, such as TCB time, zip time, etc. Next slide, please. Once you've selected a metric, in this case the subsystem metric called single phase commits, you will be given a few more choices. You might want to choose the ZOS LPAR that you want to look at, and then on that LPAR, choose the DB2 subsystem you want to look at, such as D11A. Next slide, please. Let's say you've decided to look at the connection statistics. In that case, you will have one more choice to make, the type of connection you want to see. So, if you want to see metrics for your CICS workload on DB2 subsystem D11A, you would select CICS in the connection type selection list. Next slide, please. Finally, once you've landed on a metric you're interested in, you will press the Analyze key, and you are then presented with a graph of this metric over time. You can adjust the time frame to show that metric over a time span of, say, a month or just a few minutes. Anomalies that are detected during that time frame will show up as numbered items on the graph. And you can bring that item up on the Alerts panel to get more information. The green highway can also then be used to find time frames that warrant further investigation within the mainframe piece itself, if you choose. Next slide, please. This slide is simply a list of the metrics made available to MOI from SYSVIEW to DB2 in the 4 subcategories: CPU, buffer pools, system stats, and connection stats. This is only a small sampling of all the metrics that could be made available, and we will be depending on your feedback to help us determine which other metrics to supply. Next slide, please. Now, thank you for your time. I hope this presentation encourages you to take advantage of all the ways that the CA Performance Suite of products can help you manage your enterprise. Back to you, John.
Thank you, Tom. Appreciate it. So over to Rakesh to talk about publishing insights to Splunk from MOI.
Thanks, John. Hello again. Now I'll be talking about Now I'll be talking about a feature which publishes insights generated in MOI to Splunk. So most of the enterprises are using Splunk to analyze the data of their distributed applications. They also use CA MOI to monitor the mainframe applications. Ingestion of the mainframe raw data into Splunk is very costly for the enterprises, as Splunk has licensing based on the data we ingest into Splunk. To solve this problem, CA built a solution where with minimal configuration, CA MOI can stream the insights generated in CA MOI to Splunk, which reduces the volume of data that we ingest into Splunk. This also helps the correlation of issues across mainframe and distributed applications, and the operators can manage their whole enterprise with ease. By using CA MOI to stream insights into Splunk helps the enterprises reduce the cost on the data sent to Splunk, as the data which is ingested into Splunk is enriched data and not the raw data. This also helps the operators to manage their enterprise using a single pane of glass for both distributed and mainframe applications. Next slide, please, John. So, as I mentioned, it's about the configuration. It's very easy to configure what metrics to be sent to Splunk. So, using the ISPF panel, you provide the metric name, what is the minimum severity, and the action to be taken as insights. So, for example, here I have configured that I need the job IFA percentage, MSU 4-hour average, and CPU percentage LPAR metrics to be metrics related alerts to be sent to Splunk whenever those alerts are generated. Next slide. So once the metrics are configured, you need to configure the Splunk instance information. So here you can provide an application name, the host name of Splunk, the port, and the Splunk username, and then which protocol you want to use, HTTP or HTTPS, the API secret key, source type, and the index where you want, where all these MOI alerts to be stored. And once you click save, all the alerts which are being generated for the selected metrics would be ingested into Splunk. Next slide. So once the alerts are ingested into Splunk, you can create your own dashboard or look at the metrics which you have configured in CA MOI and create a dashboard. So for example, here I have created a dashboard for all the network metrics, network packets out, network packets in per second. And if you select any one of the metric, next slide please. So if you select any one of the metrics, we drill down into the various severities for the metric, and at the bottom you see the table with all the alerts which were generated in MOI and then sent to Splunk. The operators can create a dashboard which renders all the alerts generated in distributed as well as mainframe, and he can monitor the overall enterprise. That's all for the demo. Thanks. Over to you, John.
Thank you, Rakesh. So now we'll hand it over to JD Bagnell, the product manager for CA Dynamic Capacity Intelligence, to run through that solution. Over to you, JD. I shall give you the
John. Thanks, John. Yeah, please. So, good morning, everyone. We're going to run through, since this is the first time for Dynamic Capacity Intelligence as part of the solution demo, I'm going to run through I apologize for, I thought I was minimizing that. I'm going to run through some education on what DCI is as a product, a little bit of why we are offering this, some demo visualizations of the type of information, the things that you're going to see on a daily basis, some things in support of what Makendra was talking about in issue intelligence, and then one of the new capabilities from an educational perspective of container-based pricing, which is something new that IBM has introduced into the market as part of a new pricing model for them. So Dynamic Capacity Intelligence really focuses a key part of what our strategy is as part of the mainframe. Specifically, right there in the center around economics, ensuring that you're getting the most optimization of usage of your environment for the spend that you're providing to IBM on a monthly basis, and really taking into account how can we minimize that, how can we ensure we're getting jobs through the system, and how do I just have better control of that budget and understand, what I am spending and I'm hopefully getting for the dollars that I'm spending with IBM. So the key pieces there really are what we talk about with Dynamic Capacity Intelligence, and I'm going to refer to that as DCI going forward, is really the first and main focus is really ensuring your SLAs are being met. So jobs are going through the system, customers expect certain response time. We want to make sure that you're getting that capacity associated to the workload that is most important at that point in time, and then optimizing that focus of that. We then want to look and see how we can actually potentially work and utilize the system to look at reducing your MSU usage, because that's the main thing that causes your price to go up to on your MLC on a monthly basis. Mm-hmm. And if we can give you that visualization, then it gives us a better capability actually to see, contain, and control that. So it allows us to define some policies, allows us then to determine who gets specific focus when we're actually looking at capacity management in real time. So the first thing we talk about SLA, it's one of the most important things that we're always looking for. Our customers expect certain service levels, whether that's an internal customer, whether that's an external customer, and we just need to make sure that we take advantage of that. So if we can actually look at a workload, understand the importance of that workload, and then utilize the capacity that's available to me and optimize that, then we have the capability to ensure that the SLAs are being met and potentially even making some adjustments so that we can look at new workload inside of the environment. If we look at what I was just referring to there, it really comes down to that, we continue to see growth from the mainframe. We know it's the most secure environment out there currently. We really want to make sure that we can utilize the capacity we have, utilize it by making it the most efficient way, utilizing the limited number of MSUs we can, which allows us to do two different things. Introduce new workload to the existing box that we have, and potentially not having to upgrade to that next size box because we're efficiently using the capacity that's available to us. And then the third really understanding is where peaks are in our environment, why those peaks are occurring, and how do I utilize that information to manage my MLC costs that are associated to the specific environment. So the way this actually works is that in reality we have a scenario here that we'll talk about. We have two different LPARs inside of this CAC. They each have batch and online workload. There's a total of 200 MSUs that are available, and each LPAR originally has about 50% of each one of those. But there's critical workload we see that's on LPAR 1. LPAR 2 has 3 non-critical workloads based on the definitions we're seeing. There's a question that they're only seeing the title slide. Does everybody see my screen? John?
It seems to be stuck on the title slide, JD. So.
Interesting. I'm not sure why that's happening. Let me stop sharing and start back. I apologize for that, everyone. Let me try again. Does everybody see it now? Green? Okay. I apologize. We were. I was moving through the slides. I'm not sure why. Okay. All right. Well, I'll jump to the slide that I was just on. And I'm glad that my content is better than the title slide. So what I was talking about, can everybody see this screen? John, can you see this right now? White background, a couple LPARs.
Yeah.
Okay.
Yeah.
So as part of capacity intelligence, we were talking about the SLAs, and we were talking about making sure we're optimally using the capacity that we're licensed for today, and hopefully opening workload or opening capacity for new workloads. But also understanding, what's happening in real time so we can understand how our budget or how our bill at the end of a billing period may be. We really want to actually take a look at this from a DCI perspective. And in reality, what we're doing is taking a look at capacity and making sure that the environment that has the most critical workload is getting the available capacity necessary to meet the SLA. So we're trying to use that in relation to what you're rolling for our average. Is there a capability that there might be something open? That we could actually move non-time critical workload back. So in this instance, we have 3 jobs, on one, three jobs. One's critical on one LPAR, 3 jobs on the other LPAR, and he has some extra actual capacity at this moment. And what really is happening is we define these policies in DCI is they're going to go and ask what's happening in the environment and where can I beg, borrow, and steal and still make sure my SLAs are being met. So in that instance, when that happens, and this specific LPAR with critical workload has a requirement for more MSUs and another LPAR may not be using it, even a development LPAR, we can actually borrow that capacity to fulfill our SLA needs and then readjust as the next workload definitions and then next time slide. So essentially what's happening is then DCI using that policy is making a recommendation to the HMC. HMC is actually moving those specific MSUs to the appropriate location that's deemed necessary based on the policies that have been defined. So, I mean, in reality, and I'm going to show you a visualization out here in a second, what we're trying to accomplish with DCI is really continually in real time understand what's going on with the capacity that you have, move it where it's necessary to ensure that your SLAs are met, and trying to keep it under control so that you're using the minimal number of MSUs, and then automate that process. So this is an automated process that's defined and really allows us to move beyond just an LPAR to LPAR, can go across text, and just understand what is that billing time frame. Rolling 4-hour average is that specific piece We're talking about container-based pricing, which affects that a little bit, and making sure that we understand that. But the real purpose here is, first of all, make sure that your workload is getting through the system in the most important way, and hopefully based on that, you're going to get some benefit in reduction of your overall monthly license costs. We have a customer that we talk about, Finance Informatique. They're using dynamic capacity intelligence. They've seen a nice cost savings and reduction in their MSUs. What happens usually in these type of environments, if you're interested in DCI, we'll work with you. We'll actually take 3 months of information, your latest SCRT report of what you build to what you were billed by IBM, gives us an analysis of where we think savings could happen, potentially even make a recommendation that a licensing model that you have, you may want to go to a different one based on what IBM has to offer. Multi-country pricing is a big item that can save different things on the cost in the end game and how you're actually optimizing your specific pieces. So what I'm going to do real quick is I'm going to jump into a visualization of dynamic capacity intelligence. So what I'm showing you here is our browser interface. And essentially what this is something that you can have on your desktop, but is really a view into the real-time analysis that's occurring and what's happening in the environment. So in this instance, we have 3 different tabs here. There is an ISPF version of this as well, but I'm just showing you the browser representation of that currently. As we're looking here, essentially I have a visualization of all the LPARs, the associated groups that they may be assigned to, CACs that they're assigned to, and I can come in here visually and see really quick if anything is happening, any environment is actually being capped that has business critical information on it or business critical workload on it. But it gives me an ability just to kind of look at an LPAR and kind of see the activity that's been happening on those LPARs, or even look at the group level at a higher entity and understand what's happening there and just give me a quick visualization. We also have the ability to look at the policies that have been defined. These are defined in ISPF currently, but what we do is, like I was saying in that analysis, we'll help you with the baseline development of your LPAR definitions of how much capacity range that you're going to allot to that. And that's going to be based on different things. It's going to be based on whether it's importance level coming out of WLM that's associated to what we call business critical, time critical, and non-time critical. It's going to be based on whether it's a production LPAR, whether it's a development LPAR. But we're going to look at the historical usage of that and come back with a baseline of where we think you should start. And here's the type of savings we think we can see. And as the system runs over time, then you're going to get a better handle on, oh, here's things that I can actually change that would use the system even more efficiently. And when we talk about that, a lot of times we talk about white space. And we talk about that in looking at specific different reports. And in the side of these reports that come out of the box with DCI, you can actually start to drill into more information. In this visualization, I'm looking at a certain CPC, rolling 4-hour average. I have a list of all the LPARs that are associated here, and I can actually click on an LPAR and it'll remove that LPAR, but you can see how much each LPAR actually is associated to specific workload and specific times and peaks at a specific point in time. Sorry, I'm getting a little tongue-tied here. We also have different reports, and I'll just show one real quick that I always like here. That's not the one. But we have the ability to look at things that we've identified that are business critical, time critical, and non-time critical, and do any analysis of, is there available area of actual time and that we could actually move workload around? Is there times in this peak that we can actually move back into a white space and delay the window of a certain non-critical batch job potentially to be a little bit later, but still, inside the window that's necessary for meeting its SLA? So those are the type of things that are occurring inside the environment, things you can see and things that in real time are happening, and we're addressing with that. The next thing that we're talking about was really about MOI. So from a DCI, we're doing real-time automation, capacity management. And in MOI, we want to be able to understand, okay, the capacity elements are happening in there. We need to have an understanding of that as a systems programmer or a person that's at level 1. But we also want to understand specifically, the metrics that I'm actually looking at here, how are they related to other things that are happening in the environment? This is the clustering that, I can't remember if it was Rakesh or McKendra we're talking about, but how does my capacity usage in relation to other items in specific areas that may be happening? In this instance, there's a correlation of my current MSU usage versus the transaction rate versus the MQ percentage. And it gives me the same type of information, but allows me to, that McKendra was talking about, that correlation of that information, so I have a visual understanding of how all of those pieces are coming together and how they affect each other. And if one thing is happening, does that mean the other two things are going to happen shortly thereafter if I see that type of model? Same focus. So McKendra was talking about the details about when it was detected, any type of annotations from people that have seen this in the past, who's working on it. That type of interaction and understanding of that information is key to ensure you have and are using the capacity to the greatest effect that you can. Quick run through the system. We can go into a much further detailed item as well, but I wanted to jump over for the last couple minutes that I have to actually talk about one of the new things that IBM's talking about, container-based pricing, and really what that means. So IBM introduced the concept of container-based pricing back in, I think it was last half of last year. They rolled it out to go live at the beginning of this year. But really, is a container is the ability to identify specific applications, specific workloads, specific LPARs, and I'll go through different scenarios here, that can be grouped together and build in a different metric. It could be a metric of number of transactions through that. It could be that container is built using one pricing model, like country multiplex pricing, and the rest of your system is using regular pricing. The key piece for DCI and why this it's important to understand that is, as these different pricing models are introduced, DCI is still going to take into account what's happening in these environments to ensure that the MSUs that are being built in one way can be optimized to their fullest, understanding that other pieces that may be in the container are not necessarily included inside of that calculation and analysis or that algorithm. If you look at containers and you look at mobile workload pricing, from a mobile workload pricing perspective, mobile workloads usually get a discount at the end of a billing period. Well, DCI understands that if the discount is at the end of the billing period, why can't we understand and bring that discount into real-time usage, so I understand I get to use 200 MSUs, but I'm only going to be billed for 100. So, based on containers, I just wanted to take a second, and from an education perspective, is really understanding this. We support this in the next release of DCI, which will be coming in April. And it's really identifying, like I said, categorizing workloads that can be done and agreed upon to a contract value, whatever that contract value may be. It could be one LPAR, multiple LPARs, parts. So I have some just graphical representations I'll run through real quickly. LPAR related, container-based, probably the most popular currently. A lot of customers are starting to look at this as part of their development environment. Can I, box off my development environment, have it build at a different contract allowance than the rest of my workload? That gives me the capability to potentially take advantage of some of the things that IBM's offering around development workloads. This does not mean in that container, if you have an Omegamon or a SYSVIEW or any of those type of products, even though they're in the container, they're still going to be, specifically Megamine, still going to be sold to you on a MIPS basis, a MSU basis. They're not going to be billed on the same type of rate that would be inside the container. That's one thing that needs to be understood from a container-based pricing. Multiple LPARs, and then like I said, I'm not going to go through each one of these, but there's different types of grouping, and you can see that this is going to get more complex. So as it gets complex, you need to be able to have the system automatically respond to different things that are happening in the environment and understand the correlation of elements together, what can be included in some of the optimization, what cannot be included in that optimization. But the key piece here is that this is something new that IBM has introduced. I think there's a lot of opportunity here for usage, and I think people are really starting out to do that, to understand that and start to utilize that. And really, on my last slide here really is that you still are going to be looking at rolling 4-hour averages, which a lot of you already do for your billing purposes. There's still going to be discounts. There's going to be containers included in here. You're going to have mobile workload pricing. And the SCRT gives you that information, but it's after the fact. And so with DCI, if we can take into account in our algorithms and optimize in real time, then you're taking advantage of all of the different aspects of discounts and usage and workload and making sure you're getting the throughput in the most efficient way that you can at the least amount of spend to IBM. That's all I have. If there's any questions, we can spend a lot more time on this. As you can tell, I like to talk. But we can actually set up some time offline and have some conversations. Thanks, everybody. If you have any questions, feel free to put them in the question area, and I'll try to answer them as well.
Thank you, JD.
Yep.
So, Len, could I have the ball, please? Okay, so we're at the Q&A session, and then we have a few final slides to close this out. Len, I'll hand it over to you to address the Q&A, if that's okay.
Yeah, sure. So thank you for everybody for the great session. So anybody, if you have any questions out there, if you're on the phone line and have a question, please hit #6 to unmute your line to ask your question. And if you are, again, if you're listening to this via the WebEx audio broadcast, please use the Q&A box right in the WebEx. And again, if you don't see that in the lower right of your screen right now, click the question mark icon in the upper right, and it will open up for you. And also, a little note from the community manager, we are going to have a recording of this session posted in the community in the coming days, so keep an eye out for that. If you have any questions after the fact, if you can't think of anything right now, but as you're thinking about it later or after you watch the replay, please feel free to ask those questions in the communities. If John or whoever presented the section doesn't see it in the first day or so, I will make sure that they see it. And you can also feel free to email me directly with any questions you might have. It's Len, Lenn.Thompson, THOMPSON @ca.com. And I don't see any questions coming in, John, so if you want to go ahead and move on to those final few slides, then we can do that.
Okay. Thanks so much, Len. Yeah, everyone, please send in your questions. Put them up on communities, and we'll get to them as soon as possible. Your feedback is essential for us to make sure the solution's a success. So, for those that are on the call that aren't part of the validation for CA Mainframe Operational Intelligence and would like to be, please get on and register at validate.ca.com, the CA Mainframe Operational Intelligence Validation. Once you've done that, you'll get to provide feedback during sprint reviews as we move through the agile development cycle. This enables you to influence product features to ensure they provide value to your business before those features are made generally available. Access to pre-GA materials enabling you to validate the solution and prove it in your business environment, opportunities for hands-on test drives, either hosted or deployed on-premise at your site. You can capture your data and send it into us. We'll then feed it through one of our MOI systems, Mainframe Operational Intelligence instances, in-house, and then share the insights back to you, the insights gleaned from applying machine learning to your data, so you can get a real sense for the value that MOI provides before you invest in standing up an environment at your site. And again, your feedback is very important to us. It ensures we're aligning to your business needs and developing a solution that is of value to you. You can try out CA Mainframe Operational Intelligence. It's available in a hosted environment. You can register for a trial, get access to the solution, and start using it on preloaded data and start understanding how to interact with it and the features that it provides to give you a good sense of the product. Again, before you could do that before you send us your data, perhaps, and it's a good first step to get hands-on, and you don't have to invest in standing up any hardware. Okay, some upcoming machine learning and CA Mainframe Operational Intelligence events. So IBM Think's on now. David Myers, the offering manager, who's kicked off this solution demo, is at IBM Think now. So if any customers are there, please reach out to David and he can share some additional insights about Mainframe Operational Intelligence with you. The CA Pittsburgh Technology Conference is coming up. And if you do attend that, you'll get to meet with engineers developing CA Mainframe Operational Intelligence among many other CA mainframe products. You get to talk to them face-to-face, engage with the developers doing the work, as well as the product management and pre-sales and sales folks across many CA mainframe solutions. And also keep an eye out for the CA Mainframe Virtual Summit coming up. This is a great opportunity to see the latest and greatest from the CA mainframe portfolio and engage with product experts in real time without needing to travel. So that's the end of the solution demo. Thank you so much for your time. We hope you saw value in what we presented. Please send us feedback in communities or email Len directly, and we'll get back to you as soon as we can. Have a great day,
John.
Depending on where you are in the world. And
John, there's 3 questions. There are 3 questions.
John. Yeah, John. Okay. Questions came in.
Okay.
I think 2 of them are for me, and then one of them is for the MOI team. So the question was really around the analysis that I was showing from a perspective of dynamic capacity intelligence and the overhead. The overhead is minimal. We use an agent perspective to this, and we do only collect data on 5-minute increments. So we have a core DCI controller that sits there, but on each LPAR where the agent sits, it turns on 4 seconds, gathers the data, and shuts down to return that information to the controller to make decisions. And then the controller will send any type of instructions to the specific agents as necessary. For what kind of setup does this have to move workload around? First of all, we're not moving workload. I want to make that there's other solutions out there that move workload. We're actually moving the capacity. So the workload defined for the different specific systems are still there. What we're doing is saying, if we see a specific time-critical, business-critical workload, we're going to ensure that they get the capacity they need to identify that specific SLA and address that. From a perspective of setups, we have customers that have 2 LPARs to customers that have multi-sysplex, multi-CAC setups. So it's flexible in that type of environment. We even have some service providers that are utilizing the system as well. So it can go as broad as we need it to be on that basis as well. I hope that answered the questions. And then the third question was around SYSVIEW to enable MOI and the prerequisites. So I'll let someone from the MOI team answer that.
Yeah, John, just in case you can't see it, the question is what items need to be set up within within SYSVIEW to enable MOI? Are there other prerequisite products?
Hey, can you hear me?
We can
hear you now.
Okay, so I'll have Rakesh or Machindra take that.
Yeah. So we have a couple of PTFs on top of SYSVIEW which need to be applied, and then with those PTFs there are a couple of jobs which run and ingest data to MOI from SYSVIEW, and the other prereqs are CCS common components. Those are ZData mover and CCS message service server. So these both are additional prerequisites in order to ingest SYSVIEW metrics into MOI.
You do have to be on at least SYSVIEW 14.2 version-wise for that to actually be active.
All right, great. And if you guys saw, there's another question there that just came in. Regarding DCI, what other products are needed, i.e. SYSVIEW or Ops MVS?
None of those other products are needed at this point in time. To do everything that I was showing without the integration MOI is all part of Dynamic Capacity Intelligence, the policy engine, and everything is part of that product. And like I said, we help you with analysis and are actually looking at services to provide analysis on an ongoing basis, but we can help you set up those policies and then over time help you tweak those policies to be the most efficient that they are. So DCI at this point does not need any additional products for it to actually be working.
All right, great. Thank you very much. I think that's the last question, so we're going to wrap things up for today. Again, thank you for your time. We really appreciate you taking the time out of your day to sit here and watch this series of demos. And again, I'll be posting this out in the community in the next few days. And if you have any questions, please feel free to just ask out in the community. So have a great day, and we'll talk to everyone soon. Bye.
Thank you, everyone.
Thank you. Bye.